Oh, I bet you're impressed. Beautiful Gould colours. Swimming's on tomorrow. Go Mighty Gould. Let's have some fun. Everyone else have fun too, but Gould have the most fun. All right. 10.1.10. Elimination method of solving simultaneous equations. Very straightforward. Rather than finding one variable, making it the subject like y equals or x equals, and then substituting it into the other equation, this time we get the coefficients of one of the numbers, one of the variables the same, and then we add or subtract to eliminate that variable. We'll have a look at one of each, one where I add, one where I subtract, and I think it'll all make sense pretty quickly. Over on the left here I have equation 1, x plus y equals 7. Equation 2, 5x minus y equals 5. Now unfortunately, it keeps changing the font on that for me. I'm going to make it a little bit larger just in case that's a bit hard to see on your screens. It says it's 20, but it doesn't want to behave. There we go, that's nicer. X plus y equals 7. 5x minus y equals 5. The coefficients of y have the same magnitude. They're both 1. One's positive and one's negative. If I add y and negative y, that would equal 0, wouldn't it? So that's what I'm going to do. I am going to add each of the equations. Because the left-hand sides are equal to the right-hand sides, I add the left with the left, the right with the right, and I'll maintain equality. So x plus 5x is going to give me 6x. Y plus negative y, that's 0. And 7 plus 5 is 12. Oh my goodness, how easy was that? All I've got to do is divide by 6, and I've already found my first solution, x equals 2. I haven't finished yet. Remember, we must always find both coordinates, both members of the pair of coordinates, if you like. X equals 2, I'm going to sub x equals 2 into one of the two equations, and you guessed it, in this case it's going to be a lot easier if I substitute it into equation 1. What does equation 1 become? 2 plus y equals 7. Subtract 2 from each side. Y equals 5. Therefore, the solution is 2, 5. Now, I wanted to show you something else that you may or may not have seen. These two equations, when I put them in, I used insert equation and put them in using the equation tool. The reason I did that is there is a mathematics add-in for OneNote, also works in Word and all the other Microsoft Office programs. If I highlight those equations and click graph, it's going to plot them in two dimensions for me. Let's have a look and see where the point of intersection is. The x-coordinate, you can see it's got the scale at the top and the bottom, is 2. The y-coordinate, halfway between 0 and 10. Halfway between 0 and 10 is 5. Nailed it. So there we have it. You can check your working. You don't even need to go into Desmos. You can get your working just as easily. Oh, I wonder why it sometimes slides and sometimes shrinks. That's okay. Shrinking's fine. You can see it there. So that's an easy way of checking your work and making sure you got the right answer. In an exam, use your graphics calculator. Here, you can just do it using Microsoft Mathematics. In addition, the other thing I can do with those two equations and the Microsoft Mathematics add-in, I click on Mathematics again and I go Compute. It recognizes two equations in terms of x and y. It can solve them for me. X equals 2, y equals 5. We know we got it right. How nice is that? Let's go down and look at our second example before you get stuck into some yourself. I did this last time too. It made that font small again. That's okay. When I say last time, I tried recording this once, and when I uploaded it, it uploaded a total of 3 seconds, which was not very useful to anyone. You can see I've got a little bit of a problem here. Equation 1, 3x plus 2y equals 6. Equation 2, 5x plus 3y equals 11. None of the coefficients are the same. What am I going to do? A bit of heavy-handed panel beating. I'm going to make the coefficients of one of those letters the same. I'm going to choose to make the coefficients of y the same. Could be x, but I'm going to choose y, so I can eliminate y first. In order to do that, I find the lowest common multiple of 2 and 3, which is 6. The first equation, therefore, needs to get multiplied by 3. If I multiply every term in that first equation by 3, I've got 9x plus 6y equals 18. In the second equation, to get 3y to equal 6y, I've got to multiply equation 2 by 2. So I do that and I obtain 10x plus 6y equals 22. I'm going to call this one 2 prime and 1 prime. They're still really equation 1 and 2. They've just been multiplied. You can do that, or you can just leave it as 3 times 1 and 2 minus 2. You can see now the coefficients of y are the same. So I want to do some subtraction to eliminate those. Now, whilst I could do the top one minus the bottom one, it's going to be a lot nicer if I do 2 prime minus 1 prime, the bottom one, and take away the top one. Because then I'm going to have 10x minus 9x. Well, that's just x. 6y minus 6y, we know that disappears. 22 minus 18, x equals 4. I got my answer that quickly. What do I do with that? I substitute it into one of the original equations. I'm going to choose equation 1. So I've got 3 times 4 plus 2y equals 6. 12 plus 2y equals 6. Subtracting 12 from each side gives me 2y equals negative 6. Divide by 2, y equals negative 3. So I think the solution is, therefore solution is, or the point of intersection is, at 4, negative 3. So there you have it. Solution 4, negative 3. Once again, you can check it on that mathematics if you like, or Desmos, or your graphics calculator. The elimination method is the way to go. Have fun tomorrow. Go to the mighty Gould House. We'll see you on the next one. Cheers.